Algebra 1, section 4.2, we're dealing with graphing linear equations. So linear equation is basically a graph of a line. So we're going to be graphing lines starting out at the basics. The first thing is we have to understand the equation of a line. The equation of a line is ax plus by equals c. So when you're graphing a line, you're dealing with two variables. So we're not solving, we're plugging one in and then finding a value and being able to graph. So this, remember, this x and y, it helps us find the x and y value so we know which points to put. Okay? The solution is anything that x and y makes this true. Okay, if I have an equation, for example, number 1, are negative 2, 1, and 4, 1 true for this? So that means are these points of this line? In order for them to be points, I have to get the same, when I plug them in, I have to get the same number on each side of the equal sign. So let's try negative 2, 1. This is my x and this is my y. So I'm going to plug it in. X here is negative 2 plus 5 and my y is 1 equals 3. Yes? So negative 2, 5 times 1 is 5 equals 3. Now remember, I'm not bringing anything to any side. There's no more variables, as you can see. I'm combining the terms and then I'm seeing if it's both equal on both sides. So negative 2 plus 3, I start to negative 2 on the timeline and I'm going to go up, negative 2 and I'm going to go up 5, so pass 0 onto 3. So negative 2 jumping 5 gives me 3. So 3 equals 3. So because they're equal to each other, 2, 1, yes, is a solution. See how that works? If I had another number, if I had like 5 equals 3, which is not true, then it wouldn't be a solution. Let's try the other one. 4, negative 1. My x and my y. So my x is 4 plus 5 times negative 1 equals 3. 4 doesn't need to be in parentheses anymore. 5 times negative 1 is negative 5 equals 3. 4, and you subtract 5, positive 4, you subtract 5, you get negative 1 equals 3. This does not work. Negative 1 does not equal 3, so this is not a solution. So this point would be on this line. If I graph this line, this point would be part of it. If I graph this line, this point would not, because it's not a solution. So all the points on the line, if I use it mathematically, will give me a true statement in my equation. Alright? So this one is to find 3 solutions and then graph. So what I want to do is I'm going to use a table. It's a 3-column table. This is going to be my x. In the middle is going to be my work. So here is my equation. And this is going to be my y. What this is telling me is if I pick a number, x, I choose the numbers, and I plug it in, whatever y is will then give me the x and y point. Alright? So, here we go. For example, let's just pick a number. I want to choose a range on both sides so that I can get both quadrants. So I'm going to pick 3 numbers. Remember, these numbers are the numbers I pick. They don't give it to you. There's not a magical way to get them. I'm picking them. So I'm going to choose a negative 1, 0, 1. Okay? And I'm going to plug those numbers in. I'm plugging into the equation. I don't have a y, but I did find my x, so minus 1, minus 2. So negative 1 minus 2 is negative 3. So my y equals negative 3. Okay? I'm going to do the same thing with the next number. Y equals 5 times 0 minus 2. Well, 5 times 0 is 0, minus 2 gives me a negative 2. And my last number is y equals 5 times 1 minus 2. Well, 5 times 1 is 5 minus 2 is 3. What that gives me is it gives me points. Let me show you how that works. This is my points. This is my x, so that means all of these are solutions. If I put a -1, -3, this is a solution. It proves this statement true, just like I did here. If I were to check, it would make this statement true. The next one would be 0 and -2, and the other one would be 1, 3. Okay? These are my points. I take the x and y. The middle one is just for work, so I can show my work. But once I have my work, the only things I need is my x and my y. So here we go. -1 up 3. 1, 2, 3. Here's 1. 0 down 2. 1, 2. Here's 0. Right? I start with x first, and because I don't move left and right, I stay at the origin. Remember the 0, 0? And then I go down 2. Here's 2. And then 1. So I go +1 up 3. No, something went wrong. They should be in a line. Oh, sorry. It's -1 here. -1, but I also go -3. 1, 2, 3. So here's the point. And then I go +1 up 3. 1, 2, 3. Now we're going to be using graph paper. So this is supposed to look like a line. My apologies. But on graph paper it will look like a line. But you see, this line tells me that every point on this line makes this statement true. So this is the graph of this line. Go ahead and try page 213, number 14, 213, number 14, and see if you could do it on your own, and we'll go over it in class.